So in today's lecture, we're going to be kind of covering a kind of hodgepodge of various different topics, such as implicitly typed local variables, anonymous types, extension methods. We'll also be discussing a LINQ, which is kind of an exciting kind of product from Microsoft. So let's go ahead and start with this application here. This is example code that I've created for us, just to go over these individual types. And so the way I've broken this program out is just I've created these buttons, so if you were to go into the code for each individual button, he'll just take you into that concept. And so here we're going to be talking about implicitly typed. So the var keyword, you'll notice that it figures out for you what this variable should be. Now, in my opinion, I don't like using it for this particular type of things where I'm actually declaring an integer or a string or arrays, things like that. To me, it's confusing, but again, that's kind of up to you how you want to do this. But it'll make more sense in a minute when we use LINQ why we have this var keyword, because that's really what it's for. But a lot of people also like this syntax. Now remember, this is strongly typed. So if I highlight this, you can see it actually tells me it's int I. So it's exactly the same as this. It does not mean like variant, like something like JavaScript. This is a strongly typed. This is actually an integer variable. And it figures it out from whatever's on this side of the equal sign. In this case, you can see that S is a string. Down here, you can see it's an integer array. And then down here, I'm just showing you that for each of these, I can get the type .toString. So if I were to run this and click this button, you can actually see that that's an int32, that's a string, and that's an integer array that it created for us. So the next topic is what's called anonymous types. So if I go into this one, what anonymous types allow us to do is sometimes just inline, we want to just store data in an object, but we're not really going to reuse that class. We're not going to be creating multiple objects of that class throughout our application. We just want it locally to store some data. So what we can do with these anonymous types is you can actually use this var keyword, and you can see that I highlight car, and it actually has that little A there. You can see where it says local variable, and it has like a little A and then car. And that's because it's creating this anonymous type for us. So behind the scenes, it's actually creating a class for us, and it names it whatever it wants to name it. We can do that by just using this new keyword, having brackets, and then you define the properties within that class that you want to store data for. Now, it has to be created like this because later on, this statement is not valid. All properties are read-only for these anonymous types. Now, this is an interesting statement right here where I'm saying, okay, my car, getting the type and printing it out, where before it was like string or integer array. But notice that it kind of creates this F, these underscore anonymous type 0. So again, it's just making up some crazy name for us in order to create this class. But again, you would never care about the name of the class. But you can create these anonymous types. And again, when we get into LINQ, this will make even more sense on why this is helpful. So now let's talk about extension methods. So extension methods allow you to add on methods to types that you didn't create. So for example, I've created a string and I've created an integer. Now notice what happens right here. When I say s dot, there's this new method called add one to string value. Now that clearly does not belong with these normal string methods. Why? I created it. And you'll see this little tag right here called extension, and it's saying that this class string has been extended upon. And this is actually the comment that I created for that. And so in my world, I created this extra method that it takes this string value and I add 1 to it. Where this integer value, I subtract 1 value to it. So if I say k dot, you can see sure enough there's this extension method that I created. So how do you add on extension methods to types that already exist? Well, this is how you do it. So first you need to create yourself a static class. This can be named anything you want. And then there's a special syntax for how you add on these methods. So it has to be public, it has to be static, return value, that's up to you. Here's the name of the method. And then this is the syntax that's important. This string or this integer. I don't know why they picked the syntax, just the way they did. And so if I say string dot, this method's going to come up. If I say integer dot, this is going to come up. Now we could have done the same thing for like our car or vehicle class that we created in previous lectures. But in this case, we're saying, okay, I want to add on this method here to the string class. It's going to take in a parameter called my string. I'm going to perform this algorithm on it and return this integer. So if we come back over here, you can see that add one to string value, it takes in, or it doesn't take in a value, but it uses this as that parameter value that comes in, and then it adds one to it. So the next we want to talk about is anonymous methods. So in the past, we've been working with delegates. And delegates still have their place, but if you wanted to call a method, this is the way in 1.1 or earlier of .NET, you didn't have any choice but to do this. So it's a little bit of a history lesson that we're going to go through here. So remember, delegate is just a way to create a variable that points to a method, essentially. So it's a variable that holds a method. So down here, you can see I've got this square method, very simple, just returns the square of a value. So what I can do is say, okay, I've got my delegate, which will come up here. Oop, let me just right click on it. Just peek it for now. So I did this down below. You can see that I've said delegate int my delegate int I. So what this means is that the method signature that this variable can hold, it has to return an integer and it has to take one parameter of type int. And so let me close that down. And so when I instantiate my delegate, here's the name of it, I say new delegate and I pass in that method, and now this variable holds this method here. Now in 2.0 they came up with this idea of anonymous methods, and so what we can do is we still use that delegate, but how do we put a method into it? Well, we can now use the delegate keyword. So you can see this is a way of just doing it inline. So it's writing another method inline. So if you just had a really simple method that you wanted to pass in, or you had to pass this method around, this is one way that you could do it without actually having to create, this other method here. And then that just calls the method that we just passed in. Now, another way that we can do it is something called Lambda expressions. So this new syntax, you'll see looks like this with this equals greater than sign. And so this is the parameter that we're passing into our method. And then this is our delegate that's going to go into our Lambda expression here for my delegate. And so here I'm just basically doing the same thing as above. I'm just writing some fake algorithm in order to return some data. So just multiple ways to do the exact same thing. The next concept is this one here called auto-implemented properties. And we've seen this before where we can create a variable behind the scenes automatically for us by just instantiating the property, because a lot of times we end up creating a private string and then a public property for it. Well, this allows us to just create that public property and let .NET take care of creating that private variable behind the scenes for us. So that's that. So now let's jump into LINQ. So LINQ is kind of a fun little language that we can use within C#. So what LINQ allows you to do is it allows you to write query expressions to extract data from objects or databases or lists, things like that. So you'll hear things called LINQ to objects, LINQ to XML, LINQ to SQL. And what that means is for example, LINQ to objects is when you're using LINQ to query out, you're querying some objects. You have like a list of objects and you're querying those objects. LINQ to XML, you're using LINQ to maybe parse an XML file. Or LINQ to SQL, you're using LINQ to apply it to a database that it'll write the SQL for you behind the scenes. So now with LINQ, the first thing we have to do is you have this using statement up here in order to get access to all the library that's in this LINQ namespace. And then we need some data to query. So we've just created this integer array here. Again, just some random data. It's not in any order. It's just a regular integer array. And this just prints out that data. And so now we can get into our LINQ query. You'll notice this var keyword, which it's pretty much the only way, not the only way, but it's very helpful because what it returns is based on the select statement here, and so it's nice to just have it figured out for you. Now if I highlight this, you can see it's collections.generic.IEnumerable. So it just means that there's a generic collection in here. So this could be a list. There's lots of different types of classes that implement IEnumerable. And you don't really care what it returns. You're just saying, I just want some sort of collection that I can enumerate through for example. So like a list that we've used before. So if I had a list of integers, you could use a for each statement through it. Just like this, we have this integer array, we can enumerate through it. And so now, how do we use this LINQ syntax? Have you ever used SQL? This is going to look very familiar. It's a little bit different, but it's very similar. And it's nice because what we can do is we can sort of describe what we want done, and C# will actually write the methods behind the scenes for us, rather than us actually have to write this in code explicitly. So what we can do is we can start off with this var, and this is going to be the variable that holds all of our data. It's the return type. So a LINQ query must start with the from keyword. So kind of think of this statement almost like a for each statement, basically, a for statement, where you're saying, okay, I'm going to look in this values array, and I want to look at each integer within that array, and where that value now is greater than 4. So I first use my from statement, then I can use a where statement. And so it's nice because you can see how you can just sort of describe what you want to happen. You don't actually have to write for statements and if statements and that. It'll actually do this for you behind the scenes. So it says, now give me all the values that are greater than 4. Okay, well, what did you want to select? What did you want to return? Well, I want to select each value that is greater than 4. And so you see how it says IEnumerable, and then it says int, because it's a generic collection of integers. So think of this as a list of integers, basically, is what's going to get returned in here. So every integer that is greater than 4 will be returned and now into filtered. Now what we do is we're just doing a for each statement through our new filtered list. And we can do this because it implements IEnumerable. So it's just a list that we're looping through. Now LINQ, there's one kind of feature about it that you need to understand how it works, because this is a potential bug for some applications. This right here, this statement, does not get executed on this line of code here. It does what's called lazy initialization, where this query doesn't actually get run until you start enumerating through it. So this integer, or this list here, doesn't actually get filtered until you actually enumerate through it. And that can be a little bit confusing because it does not filter those values here, it filters it here, and every subsequent time that you enumerate through this filtered list. So for example, what that means is that if I were to take this values here, okay, and here's all my values, I run it, add these values to it, run it, and then I enumerate through the values, it's going to print out all the values that are greater than 4. That's pretty straightforward. Well, now, if this next line of code, I were just to add some new values into this array, then I did this exact same statement afterwards, maybe on the next line of code, it would actually rerun this statement for me. And we'll see that again in a later example. So let's take a look now. So again, just kind of keep this in the back of your minds here. Just remember we've got this integer array and it's in values. So the next one down is we're going to, again, use the var keyword. You can see it returns us an I ordered enumerable. And that's fine. We'll see why in just a second. But again, it's just a list of integers from our values. And it says, hey, I want you to order by value and then select value. So what this is going to do now is go get all of the values and it's going to sort them by value, and then it's going to print them out. But again, remember, this isn't where the sorting takes place. It takes place on this line of code. Now if I come down here, you can see what we're doing is we're messing with this filtered now. So that's this one up here. So these are, the filtered is all values that are greater than 4. So we're doing another var. Now see, if I highlight this, you can see it's an ordered enumerable. So it's just a list of integers. But now we're querying from our filtered list. But now in our filtered list, we're going to order by that value descending and then select that integer value. This select is going to make a little more sense here in just a minute. Why, of course, they're selecting the integer value. That's all we have to select. But again, that'll make more sense in a second. And so now we're printing out all those values. And these queries, I mean, I've seen queries pages and pages long. I mean, just monstrous. Almost literally anything you do in C Sharp, you can convert it to a LINQ query if you want to. It makes it big and complicated, and I wouldn't recommend it, but it is nice for just simple things like this. And I think things like this can be more readable than actually writing out the code. Now, the other thing that you want to keep in mind, behind the scenes, C Sharp is creating this, is compiling it down into regular methods and regular C Sharp behind the scenes. So there are order by methods and descending methods that it's using behind the scenes for you. So now down here, again, we can highlight this. We can see it's another I-ordered enumerable from our values, original values. We're going to grab all of them that are greater than 4. We're going to order that value descending and then select value. And then you see it displays the filtered and sorted results. So let's go into another example here. And this is going to go over these links, and we're going to deal with an employee class. We're going to fill up an array of employees and then apply some LINQ statements to that. So this employee class just has a first name, a last name, and then a monthly salary. Here's some properties for monthly salary, and then they've overridden the toString method. This will come into play later on. That just prints out the first name, last name, and monthly salary. So a very simple employee class. So now if we come over here, you can see that we have this employee array, and we just instantiate a bunch of new employee objects and add some data to it. From there, we're just printing out to the console all that data. Now, again, this could be 1,000 elements long. But what's kind of nice is rather than having a for each statement that says, for each employee, and then, we have that employee and you say, well, employee equals, Jason or Red or 5, whatever the salary is, add it to some other array, we can use a LINQ statement to kind of do all that code for us. So you can see in this case, what we're going to do is we're going to try to get all of the employees that have a monthly salary between these amounts, 4,000 and 6,000. So see if I highlight this now, you can see it's an IEnumerable of employee. So it's a collection of employees now. So we're going to say from E in employee. So essentially this is saying, for each employee in employees, basically. Where, and now you can see how we just kind of write out what we want. We can describe what we want this query to do. Now remember, we're dealing with employee objects, so we can say E dot. And so we're just dealing with an object. And now we're pulling out its data. So we're saying, hey, for each employee where its monthly salary is greater than 4,000 and the monthly salary is less than 6,000, select E. So you're selecting the entire employee. You're not just selecting a name or an integer or anything like that now. We're selecting the entire object. So that's why this is actually a list of employee objects. And then down here is where we're actually printing out that data. And remember, that's where it actually runs this query. So here, what we're going to do is we're going to say, these are this name sorted. So we're going to go through our employees again. So from E in employees, and again, this could be named anything you want. Order by E.lastname, E.firstname. So it's going to order the objects that it puts back in this list for us. So it's first going to be sorted by last name and then sorted by first name. And if we come up here, you can see that several of these actually have the same last name. So that's why it's sorting by last name and then first name. And then it selects those objects. So we'll keep those in order. So now we'll print that out. Now there's all kinds of extension methods that LINQ has actually created for us. So now you'll notice here's our name sorted. And okay, so we've got name sorted, which is an I-ordered enumerable. And it has these employee objects in it. Okay, so if I say this name, and there's all kinds of methods that they've actually added on for us. And you see that little extension keyword? Well, we just learned about this. Well, we're adding on, we're extending methods. These are extension methods that we just learned about in this previous example over here. So remember how I had this extension method here that I added on to the string and integer? Well, that's all they've done. So they've come into this example here and they've said, okay, I wanted to add on some methods to this I-ordered enumerable. And so they added on this any method. And so that's where all these methods are coming from. They've added them on. And if I want to, I can actually right click on it, say go to definition. If I scroll to the top here, you can see here's that class enumerable. I scroll back down, If I open this up now, we can actually look at the code for how it added on this any method to the IEnumerable here. So you can see there's this keyword, IEnumerable. Tsource is the class that I'm using for, in our case, it's this employee class. And then you can see here's just the code they use, and they're just trying to figure out if there's data, return true. If there's no data, return false. So that's where this extension method comes in for LINQ. And LINQ created just a tremendous amount of extension methods. And so what we can do now is we've got this ordered list, and we can just use any of these methods that we want in order to try to figure out. So you can average things, you can see if they're equal, you can get the first, you can get the last, you can join them, get the max. There's all kinds of different methods. And this one, we're just saying, hey, if there's any values, then give me the first value. Again, you notice here's just another extension method that we can allow it to have this method this method called first applied to our list. So let's take a look at the next one now. So we're going to say last names. So now notice this one's a little bit simpler, where this is just an enumerable collection of strings. So we're saying from employees. So again, we can name this anything we want. Just select the last name. So now that's just going to select all of the last names for us. Now the thing about the last names, if I scroll back up here, remember there's multiple objects that have the same last name here for these employees. So if I scroll down, okay, so I've got all the last names, but maybe I only want to print out the distinct. I don't want to print out multiples. So I just say last names dot distinct, another one of these extension methods that you just sort of have to go through, and I figured it'd be very boring if I went through every single extension method possible. Now the next one, so let's get the first and last names, but maybe we don't want the salary. So you can see here we're going to use anonymous types. So we're going to go through from employees, select a new, so this is that anonymous type that we learned about, and we're saying just add into our object the first and last name, because we just wanted to create a simple object to hold the first and last name. We didn't want to create a class just for this and then print out that data. So hopefully you can kind of see from this just how powerful LINQ really is. So let's take a look at this last example program from the book. And so for this one, what it's going to do is just going to start off with this list of strings here. So it's even simpler than a list of objects. We're using a list of strings, and we want to, hey, we've got this big massive list. Well, now we want to look at each string and filter it based on, capitalization, or if it starts with a certain letter. And you can see they've kind of created all these different colors in here, but they've capitalized some letters, lowercase others, things like that. So first they just print out. Now I've got some breakpoints here because we're going to, at the end of this right here, the end of this program is a little bit confusing, and I wanted to put some markers in here, and so we'll come back to what those are for in just a second. So let's look at this first one here. You can see starts with R. So we're saying, okay, I want to get all of the strings that start with R. So you can see rust and red. So here's a new concept. So we've got for each item in items. This let is a way of creating a variable within your LINQ statement. So we're saying let are this new variable uppercase, and you can see if I highlight it, it figures it out. It's a string for me, kind of like the var keyword does. And I say this uppercase string is set to item.toUpper. And that way we're not worried about upper and lower cases. We're just going to filter based on everything that's uppercase. So we can say where our new variable uppercase string starts with R. That's just a regular string method. And so you can see it should return rust and red. Order by uppercase string, select that uppercase string. The next statement is just print it out. But now remember that with lazy initialization, that this doesn't actually run until we enumerate through this. So then we actually add a couple more items to our original list up here. So we're now going to add on ruby and saffron to that list. Then we're going to print out that entire list. Now here's where it gets a little bit confusing. So I'll go over it again after. Here's another for each statement. Now notice we didn't write any other LINQ query. All we did is come back to this starts with R. See, here starts with R, here starts with R, and here starts with R. Now if lazy initialization didn't take place, what would happen here? Okay, again, this is not what, I just want to repeat, this is not what is actually happening. So if this was to actually execute here, which it's not, this would get filled up with just those two values, rust and red. It would print them out. It wouldn't matter what you added on to the original collection because we're just using this starts with R. And then it would just print out those two variables again, which are rust and red. However, because of lazy initialization, we've got our query here. It runs here. We add two more items to it. One of them happens to start with red. Then you'll notice that we enumerate through this I starts with R again that was defined right here. And so it reruns this query against this items object that we just added two more elements. Sorry, I keep jumping all over the place here, but it's kind of hard to see everything. And so this is just showing you that this runs when that statement takes place. So now if I run this, you can actually see what happens a little better here. So this just prints it out. Okay, results of the query that start with R. So here, that's this one right here. So we're executing our query here, and you notice it prints out red and rust. That prints it out here. We've added two more items to it, and then they're just showing you, hey, this items collection, again, this is the original items collection, contains all of those items and these extra ones. So that's what this line is telling you here. It's showing you that original items array, or that list, contains these extra ruby and saffron. Now, it executes this for each statement. And you can see results of query that starts with R. And so here's what it was originally, and now here's it again. So you can see it's actually rerunning that same query, and that added on rust. So, or sorry, added on ruby right here. So that was the extra one that got it added on, whereas red rust, now it's red ruby and rust. So that's how LINQ works. It can be very handy. It can also be quite complicated at times, but I think as you play with it more and more, you'll just see the power that it contains. Thank you.